Namaste to all and welcome back to my class. Let us continue with electrochemistry. The topic for today is equilibrium constant from Nernst equation. The galvanic cell does not continue working indefinitely and stops working after some time. That is, as the cell reaction progresses, there is a fall in the concentration of cations around the cathode due to the reduction, and at the same time there is an increase in concentration of the metal cations around the anode due to oxidation, because when zinc is undergoing oxidation there is an increase in concentration of Zn2 plus ions, and due to reduction there is an increase in the negative ions because the positive ions are gaining electrons and getting deposited on the cathode. So there is an increase in concentration of the negative ions around the cathode part. So what happens is the electrode potential of cathode decreases and that of anode increases with the passage of time. Electrode potential of cathode, there is a reduction potential decreases, and there of cathode it increases. Ultimately a stage is reached when the potential difference, that is E cathode minus E anode, becomes zero and the flow of electrons stops. That is, in a cell of zinc in zinc sulfate solution coupled with copper in copper sulfate solution, the flow of electrons from zinc to copper stops when the electrode potential of zinc becomes equal to that of copper. So in this situation, the concentration of Zn2 plus and that of Cu2 plus ions will be equilibrium concentrations because the cell reaction has attained equilibrium. So Zn plus Cu2 plus becoming in equilibrium with Zn2 plus copper. So this reaction will attain equilibrium. So when it attains equilibrium, that is at equilibrium, Kc would be equal to Zn2 plus by Cu2 plus. That's the concentration of the ions in the product side divided by concentration of the ions of the reactant side. That is according to the equation as we have learnt earlier, Zn plus Cu2 plus in equilibrium with Zn2 plus copper. So when it has attained equilibrium, Kc would be equal to molar concentration of Zn2 plus divided by molar concentration of Cu2 plus copper, and the concentration of copper and zinc has attained unity. So E cell, that is at equilibrium, we have learnt E cell at equilibrium is 0. And so we know E cell is equal to E naught cell minus, we have learnt earlier, 0.059 by n log concentration of Zn2 plus ions divided by concentration of Cu2 plus ions. This is what we have learned, the Nernst equation of the Daniell cell. Once again repeating it, according to the Nernst equation, E cell is equal to E naught cell minus 0.059 divided by n log of the Zn2 plus ions. That is the concentration of ions in the product side divided by Cu2 plus ions, concentration of ions in the reactant side. Now E cell is 0. So 0 is equal to E naught cell minus 0.059 by n log Kc. Why? Because log Zn2 plus by Cu2 plus becomes log Kc, or E naught cell is equal to 0.059 by n log Kc. Hope the explanation is clear to you. This is how we are getting this E naught cell. Once again repeating it, E cell is equal to E naught cell minus what we have learned is 0.059 by n log Zn2 plus concentration of Zn2 plus molar concentration of Zn2 plus by molar concentration of Cu2 plus. And E cell at equilibrium is 0. So 0 is equal to E naught cell minus the same thing, 0.059 by n is here 2. Actually log Zn2 plus by Cu2 plus concentration is at equilibrium is taken as Kc. So it becomes log Kc. So E naught cell is equal to 0. That is, this can be converted to 0.059 by n log of Kc. Now next is the relationship between electrochemical cell and Gibbs energy. So only the formulas are given, like how the formula has been, the relationship has been attained is what I am going to explain, which is not here. So please listen carefully. A galvanic cell is a source of electrical energy which can be used for different kinds of work. Unlike heat energy, the electric electrical energy can be quantitatively converted into work. The electrical work or electrical energy is equal to the product of EMF, that is the cell potential of the cell, EMF of the cell, and the electrical charge that flows through the external wire. So electrical work, W electrical work, is equal to EMF into the electrical charge flowing through the wire. Now listen carefully, children. For the transference of 1 mole of electrons in the cell reaction, the quantity of electricity through the wire is 1 Faraday. For transferring 1 mole of electrons, it is 1 Faraday. 1 Faraday is equal to 96,500 coulombs. 96,500 coulombs. Now, how can we get this 96,000? The charge of 1 electron. What is the charge of 1 electron actually? Charge on 1 mole of electrons. Charge of 1 electron is 1.602 into 10 raised to minus 19 coulombs. Charge on 1 electron. So what would be the charge of 1 mole of electrons? It is 1.602 into 10 raised to minus 19, the charge of 1 electron, into 6.02 into 10 raised to 23. So that becomes equal to, it is actually 96,488, which is rounded off to 96,500. So this is how we are getting 96,500, the charge of 1 mole of electrons. So once again repeating it, electrical work is equal to EMF into electrical charge flowing through the wire. So to the transference of 1 mole of electrons, the quantity of electricity is 1 Faraday, which is equal to 96,500 coulombs. So hope how this 96,500 has come. If n moles of electrons are transferred in the cell, then the charge flowing through the wire would be n. For 1 mole, it is 96,500 coulombs, which is equal to 1 Faraday. Therefore, the charge flowing for 1 mole, for n moles would be n into F. F is capital F, means 1 Faraday. 1 Faraday, repeating, it is equal to 96,500 coulombs. For electrical work, as we had told earlier, electrical work is equal to the E cell into the charge flowing can be taken as NF. So EMF into E cell into NF, or NF E cell. Electrical work is equal to NF into E cell. Now we know that for any spontaneous process occurring at constant temperature and pressure, the driving force is provided by the decrease in Gibbs energy. That is, there should be a decrease in Gibbs energy. So the electrical work for a spontaneous reaction, electrical work should be equal to minus delta G, because there should be a decrease in free energy. And electrical work, as we have derived earlier, it is NF into E cell, NF E cell, or delta G is equal to minus NF E cell, because electrical work is equal to minus delta G. So delta G is equal to minus electrical work, and electrical work, as we have derived earlier, is NF, that is a charge flowing for n moles of electrons, is NF into the EMF, that is the E cell. So the formula becomes delta G is equal to minus NF E cell. So that is what is being written here. Delta G is equal to minus NF E cell. If the concentration of all reacting species is unity, then E cell would be E naught cell. Under standard conditions, it would be E naught cell. Then delta G naught, under standard condition, naught is not written here, delta G naught is equal to minus NF E naught cell. So these are the two formulas that we have to learn. Other than the Nernst equation, the relationship between E naught cell and equilibrium constant and delta G and E naught cell is really very important. So please go through these formulas before doing the problems. Thank you.